So, hello there and welcome to the tutorial. My name is Tanmay, and this time we're going to be going over another general education video. So actually, this was a question sent to me by one of my viewers, and here's a clip of their question.
Hi Tanmay, I'm Madison, and I have a little math question for you. What is LCM and GCF? How can I find an LCM and GCF of two numbers? Also, is there any relationship between the numbers of LCM and GCF? I will be looking forward to the next video explaining what LCM and GCF is. Bye!
So now that you've seen the question, I'm going to try my best to answer it. I hope it answers the question, Madison. Let's get started. So today we're going to be talking about the LCM and GCF. And before we go any further, what does LCM and GCF actually stand for in the first place? Well, LCM, as you can see, stands for lowest common multiple, which I'll explain in a minute. And GCF stands for greatest common factor. So essentially the opposite completely of the LCM. Now, we can ignore this part for now. And let's look at this. These are two keywords that will really help us when finding, when actually trying to do the LCM and the GCF. So there's two things here, the multiple and the factor. And so you can have a multiple or a factor of a number. For example, the number 8. I'm going to list out its multiples and its factors and then show you exactly what the factors and multiples mean. So for 8, you could have something like 1, 2, 4, and 8. For its multiples, you could have, 8, 16, 24, 32, ... They can keep going on forever. Okay, now let me explain exactly what these things are. Why have I listed these numbers exactly? What do these have to do with the number 8? Well, factors are numbers that 8 can be divided by. For example, you can do 8 divided by 4 and it will give you 2. 8 divided by 2 and it will give you 4, etc., etc. for all its factors. And the multiples are the opposite. They are the numbers that can be divided by 8. So for example, let's just choose a random one, this one, 24. Okay, so I landed on 24, 24 divided by 8, 3, perfect. So it can easily be divided, and so can this. So just to sum it all up, a factor is a number that 8 can be divided by, and then the multiple in this case is the number that can be divided by 8. You could replace this with any number, and then its multiples and factors would change, and then stuff like that. Now you must have seen a pattern here. The factors can only be less than or equal to 8, but the multiples can only be greater than or equal to 8. So this is basically how factors and the multiples will work. And so if you didn't notice already, I put a ... here. What this means is that the multiples will go on forever until infinity. However, our factors will stop right here at 8. So that's how that works. Now that we've gotten that out of the way, let's actually start using the LCM and the GCF of multiple or more numbers. And just before I go on, let me just clarify that a word for this sort of a set would mean this is a finite set, meaning there's a limited number in this. However, here, there's infinite. The in, basically meaning the opposite of finite, meaning this is infinite. It'll keep going on and on and on and on and on and on. You could do 8 times 5 million, and you would still get an answer. You could do 8 times Googleplexian, and you'd still get an answer, which is a real number, by the way. Okay, anyway, getting back to the point, let's actually see how you find GCFs and LCMs. Our main way here is, of course, going to be something called factorization trees. And before I actually explain factorization trees to you, let me explain what lowest common multiple and greatest common factor actually mean. So for example here, let's just say I wanted to find the LCM of, 4 and 8. Now what I do is I list out the multiples. For 4, I list out the multiples for 8. So for 4, there could be 4, there could be 8, there could be 12, there could be 16, etc., etc. That'll keep going on till infinity. For 8, there could be 8, 16, there could be 24, there could be 32, etc., etc., again, on to infinity. Now, as you can see, first of all, we have the word lowest in LCM. And we also have common. So you must have found out that we need to find the lowest common factor, multiple, quite literally, from both of these sets. So 8, it's in this set, so our lowest common multiple will be 8. And just as a little rule quickly, the LCM can only be greater than or equal to the bigger number in the set. So in this case, it's 8. If it were, for example, 8 and 20, it would be 20. Now let's try to find the GCF. So for example here, I'm going to write down all the factors for 4 and 8. Just to clarify, we found the LCM here to be 8. Now let's find the GCF. So let's list down the factors for 4 and 8. So for the factors for 4 would be 1, 2, and that's really, and also 4. And for 8, we could have 1, 2, 4, and also 8. So as you can see, the greatest factor that's common in both couldn't be 8 because that doesn't come in 4, but it is 4 because it also comes in 4. So as you can see, in this case, our GCF, is going to be 4. So now you must have seen another pattern. Our GCF can only be less than or equal to 4 in this case. So that's how that works. Anyway, apart from this example, now you actually know what an LCM and what a GCF is. Now you might be wondering, what's a really efficient way to do this without having to write all these factors and all these multiples and everything? This is a very manual method. It doesn't work with larger numbers, and it's just overall a very tedious process. So how can I make a way to find the same GCF and LCM easily? So yeah, we can use prime factorization. Now let me give you a few examples of that. So let's start with finding the LCM of a few numbers such as, 4 and 10. So for example, 4 and 10. Now again, we really do not want to list out all the multiples, all the factors, find the answer. It's just really repetitive. Sometimes you miss one, and it just keeps going on. And it's very unsuitable for larger numbers like 5,659 with 3,291. That just wouldn't work with listing out all the multiples and factors. So what we do in this case is we do something called prime factorization. So what we do here is, you must know what a prime number is. It's a number that can only be divided by 1 in itself. So I'm going to give you an example of something called prime factorization. So as you can see here, first of all, let's look at this number. What times 1 is equal to this number? 2 times 2 is equal to this number. So I'm going to write down 2 and 2 in a tree format. Now, basically, there's no more that we could continue, because 2 is a prime number, 2 is a prime number. We couldn't continue our tree. However, in 10's case, you also cannot continue the tree. it stops at 2 and 5. Because 2 times 5 is 10. And so since these are both prime, we can't continue to create more numbers in a tree. Just so you aren't confused, let me just show you the tree of something like 8. The reason I'm going to show this to you is so that you really get the concept of a tree in this sense. So what's 2 times 4? 8. So I'm going to write down 2 and 4. Now 2 is prime, but 4 is not. This is, forgot what that's called. Anyway, this is prime, this is not prime, sorry. So then we can continue 2 and 2. So yeah, now we've factored it down to only literally prime numbers. So now that it's only prime, we can't continue, and we have successfully created a prime tree. So now, since we can't do any of this with 10 and 4, we can only have this. Oh yeah, just remember the name. This is a composite number. It's not prime, it's composite. Okay, remembered. Okay, now let's go back to this. Since there's no more down, we just stay at one level here in the tree, and that really works out. Anyway, let's take a look at this now. Since we have treed down our 2 numbers, what we can do now is, in order to find the LCM, let's take the number 10. And let's just say 2 times 5, because that's what's written down here. Then under that, I'm going to write 2 times 2. But when you do this sort of a thing, there's a little limitation, I guess you could call it. And so what happens is, okay, look at this. You have to erase if 2 of these numbers are not the same. And what you have to do is put a little square here, another times, and then the other number. Because there should never be 2 numbers that are not the same on top of each other. So yeah, that's how that works. And so just so that you see it a little bit more clearly, I'm going to say 10 is equal to, for the sake of it. Okay. And then I'm just going to do this. And as you can see, it's that easy to be able to create something like that. Anyway, now as you can see, we have a little multiplication statement, but how do we get our LCM from it? All we really need to do is say, okay, 2 and 2, they're the same, so write down a 2. Then a multiplication symbol. 5 and blank, so we're going to write down 5. Blank and 2, or we could also write down blank. So blank and 2, we write down a 2. So our LCM is equal to 2 times 5 times 2. So it's 2 times 5, 10, times 2, 20. So our LCM has successfully been found to be 20. So that's our LCM. Now how do we get our GCF? So our GCF will just be equal to 2. How, you may ask? That's because, first of all, and just so that you can, I can draw some arrows for you. I'm going to write it above. So for example here, GCF. Now, as you can see, 2 and 2, they are common. So I'm going to write 2, then a times. 5 and blank, not common. Blank and 2, not common. So there's no more numbers at the end. We remove our multiplication, and as you see, our GCF is going to have to be 2. So we have successfully found that the GCF for 4 and 10 is 2, and the LCM for 4 and 10 is 20. Anyway, continuing on with this rule, now I'm going to show you a few more examples of prime factorization, finding the LCM and GCF with that method. So now, let's just take a few numbers, for example, 6 and 10. Okay, now we have 6 and 10, let's prime factorize them. That's done. Pretty easy. Pretty easy. Now let's find the LCM. So I'm going to note down 2 and 5 for number 10. And for 6, we note down 2 and 3. However, again, there can never be two different numbers under each other. So what we do is we erase, we make a little box, and then put the actual number, which in this case will be 3. So now that we have both of our numbers written down over here, all we can do is say, okay, 2 and 2, that's a 2, times 5 and blank, that's a 5, times blank and 3, which will be a 3. So our LCM will be equal to this. So now what's 2 times 5? That's 10. Times 3, that would be 30. So 30 is our LCM. Now that we found our LCM, let's find our GCF. Again, there's only one number that is common throughout all of these, so we can assume that our GCF is that one common number, which in this case is 2. So now what we need to do is do some more examples. So let's just do something a little bit more complicated now. 10's not that interesting because, sorry about that, they're just one down in a tree, and so that really isn't very fun if you think about it, and you really wouldn't get those many questions about that either. So now let's do something like 5 and 12, for example. So maybe 5, 12. Now 5 is already prime, so I mean we could write down 1 and 5, but there's nothing really that we would need to do about that. Anyway, but 12, that's interesting, because to get 12, you would multiply 2 and 6, and to get 6, you would get 2 and 3. So as you can see, we have a variety of different numbers now. So now what I'm going to do is I'm going to come over here. I'm going to say for 12, we have 2, so as you can see, 2 times 3, because those are all the prime numbers that we got. 2 times 2 times 3 will give us 12, because 2 times 2, that's 4, times 3, 12. Then we take our 5, right? Now the thing is, we can't just write down a 5 here. So what I'm going to do is I'm going to put a blank, and as you can, because there's a 2 in front of it, and that's not a 5, so they can't be different, so we can't put that there. So we have to do blank times another blank times another blank times a 5. And that is our valid multiplication statement. So then I'm just going to do this. And so now, as you can see, I'm going to just find the LCM by doing LCM is equal to 2 times 2 times, as you can see, because 2 blank 2, 2 blank 2, 3 blank 3, and then blank 5, 5. So we say 2 times 2, that's 4, times 3, 12, times 5 would be 24. Wait, no, that would be, I forgot what it was, let me calculate this, 60, sorry, got confused there. Anyway, but 12 times 5 would be 60, and so we can definitely assume that our LCM is 60. Now, let's find our GCF. But wait a minute. No matter what number you look at here, there's either a box below it or a box above it. This means that there's no common number. So, when there's no common number, the only thing that you can think is that the GCF will have to be 1. Cannot be any other number, due to the fact that none of these have a common number in them. Anyway, Now that that's done, let's do some more examples. Let's just finish it off with 2 more examples. This time we're going to do 8 and 12. So 12 is already there, so then we don't need to erase that. Though we can erase this and stuff. Yeah, so I'm going to give you 8 and 12 now, which I'm sure you will all love this example because it's just the perfect mix between hard and easy at the same time. So then I'm just going to do this and then just erase this. Because I mean, we're still using 12, we're just putting in an 8. So that'll work. Now let's prime factorize 8. Sorry about that. Anyway, let's prime factorize 8. So we take our 8. What's 2 times 4? 8. So 2 and 4. What's 2 times 2? 4. So we have successfully prime factorized 8 by doing 2 times 2 times 2 is equal to 8. And that's a completely valid multiplication statement. So now what I'm going to do, I'm going to come over here, and I'm going to say 8 is equal to 2 times 2 times blank times 2. Because that's actually what we're doing with 8 and 12. Now to find our LCM, however, I'm going to say LCM is equal to 2 times 2 times 3 times 2. So 2 times 2, that would be 4, times 3, that would be 12, times 2, that would be 24. So our answer here is 24 for our LCM. That was a pretty nice way to find our LCM. Now let's find our GCF. So as you can see, there's 2 common numbers in this. So there's 2 and 2. So we do GCF. I'm just going to write it here, if you don't mind. So GCF is equal to 2 times 2, because those are the only 2 common numbers there. So the GCF is going to be equal to 2 times 2, which is equal to 4. So our GCF is successfully 4. Now, if you watch the question carefully, yes, Madison did ask me how to find the GCF and LCM, but she also asked me if there was a relationship between the numbers and their GCF and LCM. And yes, there is. So let me explain that to you right now. So now I'm going to be explaining the relationship between the 2 numbers and their LCM and their GCF. In order to do this, since I don't want to bore you and spend the next 10 hours doing tons of questions, I'm just going to write down lots of GCFs and LCMs along with their numbers. So this is going to be number 1, number 2, their LCM, and their GCF. Now what I'm going to do is I'm just going to note down lots of number 1, number 2s and calculate all their LCMs and GCFs, and let's see if we can find a pattern. Let's do something like 8 and 10. That would be a pretty good example. And so I'm just going to calculate its LCM, which would be 40. So the LCM would be 40 here, and the GCF would be 2. Perfect. So our LCM and GCF is 40 and 2. Now I'm going to continue this and write down lots of numbers. So it should still be 40. This would be, okay, 4. Perfect. Then we can do something like 3 and 4. The LCM would obviously be 12. And their GCF would be 1. And I'll tell you how I calculated this in just a minute. Let's do something like 7 and 8. Let's do 56 and 1. You'll see how I calculated these so fast in just a minute now. 6 and 10. Be 30 and 2. Okay. And then we could do 2 more examples, I guess, or actually a few more examples, quite a few. 4 and 20. I don't think I have enough space for the other pattern that I was going to do. So, as I know, 4 and 20 would obviously be 20, because that's just how this works. And again, I'm going to be telling you how I calculate these so fast in just a minute. And then this would be 4. Then if we were to have something like 6 and 24, this would be 24 and this would be 6. I think you might just start seeing a pattern now, but you might just want to wait for a while and see what I really come up with next. So now that we're done 6, 24, 24, and 6, let's go to another example. 7 and 11, I guess. 7 and 11, or actually no. 7 and 11 would be too complicated for now. Or what? Yeah, I'm just going to give you a different pattern, which is 5 and 6 would give us 30 and 1. So then after 5 and 6, we have something like 5 and 7. Then our answer would definitely be 35 and 1. So then I will do a few more later, but that is if I could possibly fit them. So there are a few more patterns that I should be explaining, but those will be explained in just a minute. So now, as you know, we have number 1, number 2, our LCM and our GCF. Now, what's the relationship between these numbers, you may ask? Well, let's just look at this. What's 40 times 2? We all know that's 80, because 4 times 2, 8, add a 0, 8. What's 8 times 10? 80. So if 8 times 10 is 80, and 40 times 2 is 80, we can say that number 1 times number 2 is equal to LCM times GCF. So this is our final rule. Number 1 times number 2 is equal to LCM times GCF. That's how that works. That's a really interesting concept, and it will really help us in finding the LCM and GCF, and also to find number 1 and number 2. Now let me just show you that this exact same pattern works with all of these numbers, and then I will actually show you a few patterns in between all these numbers which you might not have realized. Okay, so let's take something like number 1 and number 2. So 8 and 20. What's 8 times 20? 160. So 8 times 20 is 160. 40 times 4, 160. So these two are equal to each other. 3 times 4, obviously 12. 12 times 1, very obviously 12. And then we can assume that they're equal. 7 times 8, 56. 56 times 1, 56. And so we can say that these are equal. This will keep going on. For example, 6 times 10, 60. 30 times 2, 60. These are equal. This will always work 100% of the time, no matter what. 4 times 20, though, just to clarify if you have any possible questions. 80. Okay, this is 80. 20 times 4, 80. And I'm just going to say that these are equal because 6 times 24, which I'm not going to do right now because that would be way too much to calculate. But, I mean, if you were to do this, it would be equal to this due to our rule saying so, so we don't even need to calculate it. We could keep going on. 5 times 6, 30. 30 times 1, 30. So then these would be equal. 5 times 7, 35 equals 35 times 1. So that's how that works. And as you can see, this rule will actually help us even though you might not think about it. Because let's say you do have your LCM, but you want to still calculate your GCF. What would you do? All you need to do is to find the GCF. You find number 1 times number 2, divided, sorry about that, a little bit too excited, I guess. Anyway. Okay, so number 1 times number 2, divided by the LCM is going to be equal to our GCF. So for example, let's find the GCF. Let's pretend we didn't have this answer. Okay? Let's pretend we didn't have the GCF. But we only had the LCM and our two numbers. So our GCF is equal to 8 times 10 divided by 40. So what's 80 divided by 40? Obviously our GCF will be equal to 2. So our GCF is equal to 2. So that's how that works, and I'm just going to give you a few more examples. Then I'm going to explain 2 or 3 different patterns that I noticed when finding your GCF and your LCM. Okay, so let's just choose one at random. Okay, so this one. Let's just try finding the LCM this time. Okay, so we don't have our LCM, we have our GCF though. So what we're going to do is we're going to do LCM is equal to 6 times 10 divided by 2. So now we do 6 times 10, which would be 60, divided by 2, 30. So our LCM will obviously be 30. And so we can fill in our 30 over there. That's how you would find the LCM and GCF using the other number. And this actually also works if you want to find one of the other numbers. So for example, over here, we didn't want to, okay, let's just say we didn't have 10. Okay, we don't have 10. But we have 32, which are our LCM and GCF, and we also have number 1. So what we're going to do is number 2 is equal to 30 times 2 divided by 6. So 30 times 2, what would that be? That would be 60. Then divide that by 6, and you get 10. So our number 2 will have to be 10, which is correct. So it will work even for number 1, number 2, LCM or GCF, as long as you have one or the other or vice versa. Okay, now that that's done, let me explain 3 patterns that I have. First of all, you may have already noticed this. If the numbers that you're calculating for are 1 apart, their LCM is equal to them 2 multiplied, and their GCF is 1. For example, 3 and 4. What's 3 times 4? 12. Their LCM is 12 and their GCF is 1. 7 times 8. What's 7 times 8? 56. Their LCM is 56 and their GCF is 1. And again, this is a rule that will work 100% of the time no matter what, as long as the 2 numbers are 1 apart. So I can give another example like 5 and 6 over here. 5 times 6, 30, and so our LCM is 30 and our GCF is 1. So that's basically how that works, and so that's one of the patterns. Now let's see another pattern, and you might have really not seen this because I haven't shown you an example of this yet. However, now I'm going to erase a few of these, till there I guess. And so this pattern is really interesting, so you're really going to like this one. Okay, watch this. If I have number 1 as like 7, then 11, like the earlier one that I was giving you, its LCM will be 77, and its GCF will be 1. But yeah, wait, you must be thinking, these aren't 1 apart. Like, what's happening? Well, I'm going to give you a few more examples, and maybe you'll find out. For 3 and 7, guess. 35, you're right. Alright, sorry. I made a mistake. I thought I made a mistake. Anyway. Forgot to do that, and it's actually 21. But its GCF will always be 1, and I can guarantee to you that the next one will also be 1, and you'll see how I thought that in just a minute. And I don't even know these 2 numbers yet, and I know that it's going to be 1. So I'm just going to think, and so 5 and 7. Okay. So its LCM would be 35. Now I want you to guess what the pattern is. The pattern is that if number 1 and number 2 is prime, then the LCM will always be their multiplication and their GCF will be 1. That's how simple that is. Same thing for this, because 3 and 7 are prime. 3 times 7, 21, 21 and 1 for the LCM and GCF. 5 and 7 prime, 5 times 7, 35, 35 for the LCM, 1 for the GCF. That's how that actually works. So those are the patterns that we could discern from these little numbers and LCMs. And I really hope that answers your question, Madison, because that was pretty much, I guess, it for this video. And wait, just one more thing. I forgot to show one last pattern to you. Let's just do this. Number 1, number 2, LCM, GCF. Okay, so the last pattern is, let's just say we have 4 and 20, and also 6 and 24. I can immediately guess these. If you can't guess why, I don't blame you. It's a pretty hard pattern to find. You do realize that it's basically just a mirrored reflection of the number 1 and number 2, but you don't understand why yet. Let me explain. If the bigger number is a multiple of the smaller number, then the LCM will be equal to the bigger number, and the GCF will be equal to the smaller number. That's just how it works. So for example, 4 and 20. 20 is a multiple of 4. So then our LCM will be the bigger number, which is 20, and our GCF will be the smaller number, which is 4. And that's how that rule works. That is the last, really last rule. So I guess that's pretty much it for this video. Now I'm going to say my outro, as always. However, if you, sorry about that, that actually hurt. Anyway, there is a bit of a longer example at the end of this video, so if you want to stick around, please do. But as always, for the people that don't want to stay around, I'm just going to say my outro. So yeah, subscribe to my channel if you're new, like the video if you liked it, comment down if you have any questions or any suggestions for any apps, and that's going to be it. Goodbye to everyone who doesn't want to watch the longer version, but hello to everyone who's joining in for the longer version. So, let's try our best to find the LCM and GCF for two numbers, pretty huge numbers, like 24 and 64. Okay, now how would we go about doing this? What we're going to do is we're going to use the same method as always, which is basically just factor these down, use multiplication. It's going to be a little hard to do because there's so many factors, but again, this is not a really, realistic example. You wouldn't ever have to do this. You would usually use a calculator or something, but just in case you were ever posed with this question, it probably wouldn't even fit on a few pieces of paper, but I'll show it to you anyway. So for 24, what we do is 2 times 12 is 24, then 2 times 6 is 12, and then 2 times 3 is 6. So we have successfully prime factorized 24. For 64, however, it's a bit different. 32, because 2 times 32 is equal to 64. Then 2 and 16, because that's what that's equal to. 2 times 16 is 32. Then, to get 16, we do 2 and 8. Then to get 8, we do 2 and 4. And to get 4, we do 2 and 2. Now, what we need to do is we need to write down our multiplication question and then just solve it. That's how simple it is. So what I'm going to do is I'm going to come over here. 1, 2, 3, 4, 5, 6. There's 6 2's in 64. So I'm going to say 64 is equal to 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Okay, so there's 6 2's in 64. Anyway, now 24. Let's say 24. 1, 2, 3 2's. So I'm going to say 1, 2, 3. Then times a box, times a box, times a box, times a 3. So now we have to find our LCM, and we're going to do that by multiplication, as always. So then LCM is going to be equal to 2 times 2 times 2 times 2 times 2 times 2 times 3. Now again, you could just go 2 times 2 is 4, then 8, then 16, then 32, then 64, then 192, but that's boring. And plus, if you didn't already know the answer to this question, you wouldn't want to go through this entire thing. And also, if this were much bigger, for example, like 10 more 2's, you wouldn't keep on doing that. So I broke it down into multiple little sections, which I like to call a multiplication tree. So then we just take 3 parts of this question, 2 times 2, 2 times 2, 2 times 2. So the answers to these will be 4. Now what we do is we find the answer to these two. What's 4 times 4? 16, obviously. Okay. Then we bring the 4 down, down here. We have to find 16 times 4. So I bring that down to 16 times 2 times 2. Same thing. It's easier to solve too. So 16 times 2, 32, times 2, 64. So then our answer here is 64. And then finally what we do, we bring down our 3 over here, so 64 times 3, which sometimes you would need a calculator for unless you're really good at multiplication mentally. But I know that the answer here would be 192. So our LCM in this case for 24 and 64 would be 192. Now if you wanted to find the GCF, however, what you would do is, again, you would take the common ones, and just to do this easier, I'm going to make another box. So there's 3 2's that are common, so I'm going to say the GCF is equal to 2 times 2 times 2. There's only 3 numbers common. So 2 times 2, 4 times 2, 8. So our GCF is equal to 8, and our LCM is 192 for 24 and 64. So that's how you'd solve that. And yeah, that was pretty much it for this video. And yeah, subscribe to my channel if you're new. Like the video if you really liked it. Comment down if you have any questions, suggestions, app ideas, video ideas, algorithm ideas. You can even email me some videos of yourselves asking questions at tadgymani@gmail.com. My mail will be down in the description below. And that's it. Goodbye.